Okay, for this unit, we're going to be moving into radicals, right? Some people call this square roots. That you guys see my sign in question number 1. People call that square root, but square root is when the base is 2. The bases are usually going to be a number outside of the radical sign. We call that the radical sign. Let me emphasize this right here. We call that radical sign. If we don't see the root, the numbers outside, kind of like right here, when we don't see the root, we say the root is 2. So we call that square root. But the root can also be here. Question number 2, you guys see my 4 there. What it means is the root is 4. Now, interesting part is that radicals, that's what basically undoes an exponent. It's the opposite of an exponent. Here, because the root is 2, I gotta think of the squares. Now, what I mean with squares, I gotta know what's 2 squared. I gotta know what's 3 squared, 4 squared, 5 squared, 6 squared, as far as I need to go. I'm gonna stop at 7 squared, actually. Right? I need to know my squares because I'm dealing with the square root. If I was dealing with my root was 4, my exponent is to the 4. So I know 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. And 7 squared is 49. Right? The exponents, we're familiar with those. We're in algebra 2. So we're familiar with those. Now, the way I'm going to split my radical, I'm going to simplify this. Let me worry about the number for this moment. So I'm looking at square root of 125, right? Radical of 125. The way I'm going to split this, I'm going to split it into 2 radicals. They're still going to be the same root. So square root. I want to think of 2 numbers that multiplied equals 125. But one of my numbers, right? One of my numbers has to be from this list. I'm dealing with the squares, so it has to be a perfect square. So I'm thinking 2 numbers that multiplied equals 125, but one of my numbers has to be either 4, 9, 16, 25, 36, or 49. In my case, I want to think 25 times 5. Right? 25 times 5 is 125. 25 comes from my list because I know the square root of 25. Isn't that just 5? So I was able to get a perfect square. Now, this 5 with the number that was outside to begin with, in this case, a -3, let me multiply those out. 5 times a -3 gives me -15. And then inside my radical, I still have a 5. And I'm talking about this 5 right here. Number-wise is that. Then I even think, can I do better? Can my square root of 5, can I break this into 2 numbers? 2 numbers that multiplied equals 5, but one of them is from my list that I have at the right. I cannot. So I'm done. I cannot simplify number-wise. Now letters. Inside, my exponent is 1. My root is 2. In order for a letter to come out of the radical, my exponent on the inside has to be bigger than the root. So in this case, I cannot. My x has to stay inside. Okay, so that's it. My number is -15, radical 5/6. How am I going to type this? All right, the -15 is easy. -15. Now the radical 5x. The way you guys are going to type this, I'm going to abbreviate radical as just RAD for rad. The 5x is inside the radical, so I'm going to type it inside parentheses. So I have -15 radical 5x. That's it. Let's take a look at question number 2. My root is a 4. So now here I'm not doing squares, I'm doing 4 roots. So I gotta remember what's 2 to the 4th, 3 to the 4th, 4 to the 4th. My exponent is the same as the root. I'm gonna go up to 6 to the 4th. I think that's enough. 2 to the 4th is 16, right? Multiply 2 4 times, right? 2 times 2 times 2 times 2. 3 to the fourth is 81. Right? Multiply 3 times 3 times 3 times 3. 4 to the fourth is 256. 5 to the fourth is 625. And 6 to the fourth is 1,296. All right, so now I'm looking at my radical. It's radical base 4. And I'm thinking, all right, inside is a 324. Okay, and I think of 324 as a multiplication of two numbers, but one of them has to be from this list right here. Could 16 be a possible number? Let's see. I'm going to use my calculator. I'm going to go 324 divided by 16. I'm going to use division to go backwards. 324 divided by 16 gives me a decimal. So I'm going to say 16 is not a good number to choose. How about 324 divided by 81? 324 divided by 81 gives me 4. So guess what? The multiplication I'm thinking is 81 times 4. Right? 81 times 4 is 324. The fourth root of 81 is 3. You guys can see where I got that from. Now this 3 that just came out with this -7 that was outside, I'm just going to multiply those out. So I'm going to have -21, the fourth root of 4. Then I even asked myself, can I do better with my radical? The fourth root of 4. I know some people is like, oh, we can do the square root of 4, but I'm not asking for the square root. I'm asking for the fourth root. Can you think of a number multiplied by itself 4 times equals 4? Now we cannot. Okay, so nothing I can do with my radical. Now letter-wise, I said earlier, in order for part of my letter to come out, my exponent, let me emphasize, the exponent on the inside is 6. The root is 4. In order for a letter to come out, my exponent has to be bigger than the root, which in this case it is. Let me write, because it's x to the 6, let me write my x 6 times. 1, 2, 3, 4, 5, 6. Right, if it was x to the 7th, write it 7 times. X to the 6th, just write it 6 times. My root is 4. What I'm asking here is, how many groups of 4 can you make? I can make this group. Again, the question is, how many groups? Just one group. So on the outside, I'm going to have x to the 1, which is just an x. If I was able to make 3 groups, I would write x to the 3. Now, those that I was not able to make in groups, in this case, we usually call this remainder. I mean, my remainder is I have x twice. So inside of the radical, I'm going to write x to the 2nd. My exponent, when I look inside of my radical, my exponent has to be smaller than the root, right? 2 is smaller than 4. So that's it. That's my answer. Now, how am I going to type this? Okay, let's take a look. -21x is just not that bad. Now my radical, I'm going to write, in this case, I'm going to write rad 4. And in parentheses. Rad 4, the 4 is basically indicating the root, right? The root is 4. When we do square roots, we just call rad. We don't have to write a 2. But here, I'm going to write rad 4, right? Radical root 4. Now, inside of the parentheses, I'm going to write what I have inside the radical. I have 4x squared. So I'm going to write this as 4x. And then for the exponent, I'm going to use this caret. We call this caret. Looks like an arrow pointing up. Right, you guys see it on your keyboard, right, where the 6 is? So shift 6. And that's it. -21x radical 4. So root 4. Inside the parentheses, I have 4x squared. Notice for my exponent, I'm using that caret sign. All right, let's take a look at question number 3. My root is 3. So when I'm thinking of my list of perfect cubes, I'm thinking, what's 2 to the third? What's 3 to the third? 4 to the third, 5 to the third, and so on. Okay, I need my exponent to be to the third because the root is 3. Now, 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. And 5 to the third is 125. I could do 6 to the third, but that's 216. That's kind of big because the number inside my radical is just 128. So make sure these numbers don't go past 128. You're not going to need anything bigger than 128. So I'm looking at my radical, right? Is radical root 3. So I'm thinking two numbers that multiplied equals 128, but one of them has to come from my list. It's either 8, 27, 64, 125. I'm going to use my calculator to find this. I start with 128. What if I divide it by 8? Right? That's my first number here. 128 divided by 8 gives me 16. Okay. So I'm going to use the 8 and I'm going to use the 16. Right? 8 times 16 is 128. I know the cube root of 8 is 2. So this gives me -6 cube root of 16. My -6, because I multiply this 2 with the -3 that I had outside to begin with. And then I look, the cube root of 16. Can I do better? In this case, I can. Okay. So I'm going to split this as 2 radicals, cube root. So I'm thinking, all right, two numbers that multiplied equals 16. I'm going to go 8 times 2. I can choose 8 because it's 8 from my list. I know the cube root of 8 is 2. Now this 2 multiply with this -6, going to give me -12 cube root of 2. So I'll just worry about the numbers to begin with. Okay. Cube root of 2, nothing I can do. So that's it. Now letter-wise, my exponent inside is 2 and my root is 3. In order for me to get part of my letter out, the exponent has to be bigger than the root. Right? 2 is not bigger than 3. So the n squared, all of it stays inside. That's my answer. How we're going to type this, let me go -12 rad 3, because rad root 3, and inside parentheses, I'm going to write 2n to the second. Notice how for the exponent, I use the caret sign. All right, that's not bad. Let's take a look at question number 4. The root is 4, right? So let me think of my exponents to the 4th. I want to know what's 2 to the 4th, what's 3 to the 4th, what's 4 to the 4th. Let's see, so 2 to the 4th is 16. 3 to the 4th is 81. 4 to the 4th is 256. Okay, I'm going to stop there because the number that inside of my radical is 96. So I'm going to break this thing up. Okay, two numbers that multiplied equals 96. One of my numbers has to be from this list. So I think I'll go, how about 96 divided by 16? All right, 16 is my first number. 96 divided by 16 is 6. So the numbers I'm going to choose are 16 and 6. Right, 16 times 6 is 96. I know the 4th root of 16, right? Which number multiplied by itself 4 times gives me 16th? The 4th root of 16 is 2. This 2, with this negative sign that was outside of my radical to begin with, that becomes -2 Then I have the fourth root of 6. Now, can I do any better? No. All right, the fourth root of 6, nothing I can do. Letter-wise, I have inside of my radical, my exponent is 2. My root is 4. In order for part of the letter to come out, my exponent cannot be smaller than the root. So nothing comes out. So I'm going to keep the m squared inside the radical. Now that way I'm going to type this. I'm going to go -2 rad 4 because it's radical root 4. And inside my parentheses, I'm going to write 6m to the second. Let's take a look at question number 5. The root is 3. So I'm thinking, what's 2 to the third, 3 to the third, 4 to the third, what's 5 to the third? The root is 3, so that's the exponent I'm going to use. I know 2 to the third is 8. 3 to the third is 27. 4 to the third, I know is 64. 5 to the third is 125. I could go more, but I think that's enough. I'm thinking, all right, I got to split this as 2 radicals here. 1,000, right? That's the number that I have inside. And I'm looking at this list. I'm gotta think of 1,000 as a multiplication of 2 numbers, but one of my numbers has to be from this list, right? Easily we can think 100 times 10, but neither the 100 nor the 10 are part of my list. So no, I cannot do that. But let's see, I'm gonna use my calculator. How about 1,000 divided by 8? 1,000 divided by 8 is 125. So 8 times 125 is 1,000. I know that the cube root of 8 is 2. Now, the nice thing is that the cube root of 125 is 5. I don't have any more radicals. At least number-wise, I don't have radicals. I'm just going to multiply the 6 that was outside to begin with this 2, with this 5. I'm going to go 6 times 2 times 5. And I know that's 60. So number-wise, I have 60. Inside my radical, I don't have any more numbers because my radicals cancel out. Now let me take a look at the letters. The exponent is 5 and the root is 3. My exponent is bigger, so I can simplify this. So it's r to the 5. So let me write r 5 times. My question here is, because the root is 3, let me make groups of 3. There is 1 group. And my question here is, how many groups did I make? So I'm going to write r to the 1, right? Or r just 1 time. And then the leftovers, the remainders, what goes inside the radical. I have r to the second. So I'm going to type this as 60r. Then I'm going to type in radical 3, because the root is 3. And inside parentheses, I'm going to write r to the second. Question number 6. I don't see the root, right? I see the radical, but I don't see the root, the number outside. When we don't see it, the root is 2, right? That's how we call the square roots. That's what they're called, square roots, because squared, right, the root is 2. So because I'm dealing with the root 2, I'm going to say, well, what's 2 to the second? What's 3 to the second? 4 to the second? 5 to the second? Right, as far as I want to go. I know 2 to the second is 4. 3 to the second is 9. 4 squared is 16. 5 squared is 25. Like I said, I could go on and on and on. All right, let me simplify this out. So my square root, I'm gonna split it into 2. And I'm thinking 128, I have to write it as a multiplication of 2 numbers. One of my numbers has to be from here. And I think 128 divided by 4, I know is 32. So I'm gonna break this as 4 times 32. I know the square root of 4 is 2. So that becomes a whole number. This 2 multiplied with this 4 that was outside to begin with, I'm gonna have 8 square root of 32. Okay, now think about it. Can we do better? Yeah. Square root of 32, let me split it as 2 radicals. Some people might be like, I can think of that as 4 times 8. I know the square root of 4 is 2. So that became a whole number. Now 2 with this 8 that was outside, I was gonna give me 16 square root of 8. Can you simplify it more? Yes. My radical 8, I'm gonna break that as 4 times 2 because the square root of 4 is 2. Now this 2 multiply with this 16 is gonna give me 32 radical 2. Okay. Numbers wise, that's as far as I can go. Now letter wise, inside I see 8 to the second. So what does that mean? I have 8 twice. My root is 2. So now my question here is, draw this, we'll get groups of 2. There you go. I can get one group. So I'm gonna have a to the 1 outside. Inside the radical, I don't have any remainders. So there's my answer, 32a radical 2. The way we're gonna type this is 32a radical 2. Okay, let me zoom out. That's what we did.